Welcome back to Next App, where we have a look at certain interview questions that might come up, one question at a time. We look at the question, then we do a little deep dive into any useful background information pertaining to that question, and then we look at a concise answer for that question. So today's question is going to be, why do we have max pooling in CNNs, convolutional neural networks? Which is a question that's asked for machine learning interview questions, computer vision interview questions, and neural network interview questions. And the deep dive for today is at a Quora page. Somebody asked the question about why should you use what is max pooling in convolutional neural networks. So we basically have an understanding of what max pooling is and how can it be useful. And the top answer came by Jay Rico. I'll just be sure that is this from Jay Rico? Yeah, looks like, right. Top answer from Jay Rico. Max pooling is a sample-based discretization process. The objective is to downsample an input representation, reducing its dimensionality and allowing for assumptions to be made about features contained in the subregions binned. This is done in part to help overfitting by providing an abstracted form of the representation, as well as reduces the computational cost by reducing the number of parameters to learn, which is the key thing. So it's like kind of, you take a bigger window and then just pull one value out of that window. And that generally just reduces the amount of data that's being passed through. It reduces the computational cost by reducing the parameters to learn and provides basic translation invariance to the internal representation. This is due to the fact that no matter where that maximum value occurs, top left, lower right, it's gonna be that maximum value that you're gonna pass through. Max pooling is done by applying a max filter, usually non-overlapping subregions here, right? So they have this depth slice that is going to be represented with 4 different 2x2 filters with a stride of 2, is meaning like there's like no overlap here. And out of these 4 filter results, they take the maximum value each. For the red region, it's going to be 6. For the green region, it's going to be 8. 4 for the blue region, and 3 for the yellow region. And you can see already that basically each position within the filter can be a candidate for the maximum value, right? So here we have lower right, lower right again, a lower right, and here suddenly we have upper left. Each of those candidates can become the maximum value, and this maximum value is then passed on. If you look at like some sort of image example or like a convolutional block that you have here, then you pull the maximum value out of it, changes automatically the dimensionality, right? Because here what we do is like we have a 2x2 filter from which we only gather one value. So that means just arithmetically we have to divide x and y by 2. So 224 becomes 112, 224 becomes 112. And the third dimension, like the different filters, still stays the same. And kind of resembles like an image downsampling approach, right? Just like take the maximum value and pass that on. Kind of resembles the downsampling process. So that's the background, and I think like the key words to remember here is that it's reducing the number of parameters to learn, which is like a key improvement for like the runtime that you need just in order to train your neural network. And the second key thing is like this invariance, that in computer vision scenarios is a key part. Like if you want to look for certain features in the image, like low-level features, they can arise at any given rotation and translation and scale, so to say. And there are a lot of filters out there that are optimized in order to be invariant for exactly those occurrences, and just trained to like still find that feature no matter where it is in the image, and how it is rotated in the image. And max pooling kind of is like a subpart of that, because it is invariant towards the translation. So with that, we go back to the key answer. Key answer here is max pooling in CNN allows you to reduce computation. Right, that's what we just figured out, since our feature maps are smaller after the pooling, smaller after exactly how big your filter size was. You don't lose much semantic information since you're taking the maximum activation. And then this is the second thing that's briefly touched upon, is there is also a theory that max pooling contributes a bit to giving CNNs more translation invariance. And that's basically the key thing to keep in mind whenever you are being tasked with that question, to basically tick off those two key advantages of max pooling. First is reduction in dimensionality, and second is, and they see here according to theory, it gives CNNs translation invariance. If you remember those two key facts, you're ticking off basically the two key advantages of max pooling and why it is justified to have max pooling within convolutional neural networks.